right, these are the notes for 2.2, the last page of those notes. So we've done graphing and the parts of quadratics when we were given vertex form and standard form, and now we're given intercept form. So the parent function of that looks like this, where we have a times x minus p times x minus q, and p and q are those x-intercepts. So in this equation, if I want to list my x-intercepts, a plus 4, well, it's minus p, so that'd be a negative 4. Whenever it's grouped with x, it's always the opposite thing. I have one at negative 4, and I have one at a positive 2. So if I put this on the graph, those are my x-intercepts, and it does say to label them. Pay attention to what it says to label, as well as it says graph the whole function. So we will end up graphing this entire function. But this is the point, negative 4, 0, and this is the point, 2, 0. Okay? The next step for these graphs is to draw the axis of symmetry. Okay? The equation for that is p plus q and a divide by 2. It's halfway between the 2 points. Well, in this case, it's easy to see because I have six units in between. So if I go over 3 units from both, there's my axis. And that is the equation x equals negative 1. And then I need the rest of my graph. Now, there's multiple ways to find the full vertex. I know the x value has to be on that axis, so it's going to be a negative 1. I just don't know what y is. So you can use multiple ways. I'll show you how to do more than one. Okay, so let me show you. If I take the calculator, oops, clear all that. There's a lot going on. I know negative 1 is what x is. So if I plug negative 1 in, everywhere I see x, it will give me my y. So if I say negative 1/3, which is 1 divided by 3, parentheses, negative 1 plus 4, I just plugged in the negative 1 for x, and then I have a negative 1 minus 2. It's this equation. It's just everywhere it said x, I put in negative 1. And if I push enter, then my y is 3. Okay? Another way to see that is you had points to memorize. We had 1, 1, 2, 4, 3, 9. And we need these anyways for graphing the rest of this, okay? So if I'm saying my vertex is at negative 1, 3, I can put that. But I don't want to just put my curve. You need to put more than 3 exact points. My multiplier here is a negative 1/3. That's what a is. So I take y and I multiply by a negative 1/3. So 1 becomes a negative 0.3, 4 becomes a negative 1.3, and 9 becomes a negative 3. So I could have also looked at this and said, well, I know these points are 3 units away from the axis. This gets me 3 units away from the axis. So if from my vertex I go right 3, down 3, then from one of these points, I'm going to do the opposite. I'm going to go left 3, up 3, and there's my vertex. So I could have used this to get to that vertex as well as plugging it in. But plugging it in will always work. Sometimes this won't because we might have decimals and other things that between points that we don't have on our chart of points to remember. But if I go ahead and plot these points from my vertex, I go right 1, down 1/3. I go right 2, down 1 1/3. And I go right 3, down 3, and it is to those points. So this graph is going to look like this. Okay? So I graphed the function. I have labeled the x-intercepts, and I've labeled the line of symmetry, but I have not, or the axis of symmetry, I have not labeled my vertex yet, so it's negative 1, 3. Okay? So now I move on to number 5 here. Now, my x-intercepts for number 5, this is the same thing as saying 2 times x plus 0 times x minus 2. Okay? If it doesn't have a number in there with the x, that means one of the intercepts is 0. The other one is going to be the positive 2. So if I graph those, okay, my axis is the line directly between those, which is when x equals 1. So if I label, sorry, forgot. 2, 0, and 0, 0. My axis is going to be right here, which is the line x equals 1. And then I need my vertex. Now I know the vertex, x is 1. I need to find y. So again, you can plug it in your calculator where you're going to have 2 times 1 times 1 minus 2. Okay, so it's going to be 2 times negative 2, or I'm sorry, negative 1. So it should be negative 2. You can plug it in your calculator if you need to, or just do the math out like that. And so my vertex, if I go up 1 and I go down 2, this is 1, negative 2. And then I have those points to remember. 1, 1, 2, 4, 3, 9. And I multiply by 2. That's my a in this problem. So I'm taking y times 2. So that becomes 2, 8, 18. And then I can graph those from that vertex. And that also helps me check to make sure these are points that are on my curve. So they may not be exactly on your curve. That's why you want to get in the habit of plugging it in. Because if it's not on the curve, on these exact points, it might be, oh, maybe you only go over a half. And that's not one of the points we're graphing, but it'll still be there. So that's why you need to plug in to find y, then graph these from that vertex. So from 1, negative 2, I'm going to go right 1, up 2, and that does put me right on that point. Then I go right 2, up 8, which is slightly off of my graph. I kind of right into that equation I wrote. Whoops, it goes here. Couldn't see. All right, and then I make the curve. All right, so I double check, I graph my graph, I labeled my x-intercepts, the vertex, and the axis of symmetry. So I am good on this problem. All right, so number 6 down here is going back to standard form. Standard form is where x is going to equal a negative b over 2a. I'm just writing that down so I don't forget. That's the type of equation I'm going to be using because this is a. This is B, 3 is C. And it tells me X is the distance from home plate, and it tells me Y is the height of the ball from the ground. So if I know this is quadratic, so I'm going to have this curve of a U here. If this is the batter where the batter's hitting, and it's going to go in this curve. The vertex will be right here. This will give me some X and some Y. The Y is the height. Whoops, so that's the y. The x is the distance from home plate. So it's really the distance the batter hits it, but that's only the distance to its highest point, but then it goes back down. This is also x, okay? So that's the total distance it goes. So if I find x, I plug in, I have a negative b, which is 0.2127, over 2 times a, which is a negative 0.0005. And you can just plug that in your calculator, but when you do, make sure everything on the bottom is in parentheses. Because if you just type this in as negative 0.2127 divided by 2 times this, without those parentheses, it'll divide by 2 and then it multiplies. So you have to put the parentheses around so it divides by all of that. All right? And you'll get 212.7 feet. So that's what this is, 212.7. Okay, and then there's a comma. And now I need to find the y. I'm going to find the y by plugging that in for x. So y is going to equal negative 0.005 times 212.7 squared plus 0.2127 times 212.7 plus 3. You just plug all of that in your calculator, and then you should get 25.6. Okay, so the first question says, what is the highest point the ball will reach? It'll reach 425.6 feet. That's the highest it goes, because then it's going to start dropping again. And then it says if the ball was hit to center field, and center field is 410 feet from home plate. So I don't know how far, but I know it's 410. And then it's got a fence that's 8 foot high. And it wants me to hit or see if this was a home run. So I need to see really how high this curve is at 410. So what I'm going to do is I'm going to, instead of plugging in 212, which was my vertex, I'm going to plug in 410. So everywhere you had that, plug in 410 instead. Okay? That ends up giving you y equals 6.16. So that is its height at 410 feet. So even though this ball from the start to the end, it's going to end up going, what, a total, till it hits the ground again, what, 225.4 feet? But the curve with it going down, it's not going to clear the fence. It really hits the fence at 6.16 feet and bounces back. It's not going to clear that fence. So when it says, was this hit home run? The answer would be no. It hits the wall at 6.16 feet high. So it did not clear the fence.